Ever looked at an ESP32 and wondered what every single one of these pins actually does? Well, you are in the right place. Today we are going on a complete tour from VIN to GPIO 23, and I am going to explain the function of every pin on this board. By the end of this video, you will have the complete map to build whatever you can imagine. This little ESP32 board is a powerhouse and it's behind so many incredible DIY projects. But to really unlock its potential, you have got to speak its language, and that language is spoken through these pins. Before we get into these pins, let's do a quick meet and greet with this board itself. First thing to know, the brain of this operation, the ESP32 chip, is made by a company called Espressive. Think of the ESP32 as a tiny super smart computer chip, also known as a system on a chip or SoC, because it has so many parts packed into one. It's also a microcontroller or MCU, which means it's a small computer designed to control other electronic stuff. The board you are holding might be from a different company, so it could look a little different, but don't worry, the heart and soul are the same. Now let's talk about the big metal rectangle right there. This is the ESP32 WROOM module. Inside this metal shield is a crazy fast dual-core 32-bit processor that can run up to 240 MHz. Imagine your brain being able to do two big tasks at the same exact time. That's what dual-core means for the ESP32. It can multitask like a champ, maybe handling Wi-Fi communication with one core while running your main program on the other. It's got built-in Wi-Fi and Bluetooth, 520 KB of internal SRAM, and a 4 MB flash chip, plus a bunch of other supporting components all packed into this one module. This metal cover isn't just for looks. It's a RF shield to block electromagnetic interferences. Think of it like a tiny metal fence that keeps unwanted radio signals from messing with the chip inside and also stops the chip from sending out its own unwanted signals. And it acts as a heatsink to keep the chip cool. Just like a radiator in a car, it absorbs heat from the hot chip and spreads it out into the air through its fins, preventing the chip from getting too hot and getting damaged. And if you could peek underneath the metal cover, there it is, the actual ESP32 DOWD chip. Down here, our trusty micro USB port provides power and our connection for uploading code. It's like the board's charging port and its data cable all in one. Now next to it, these two buttons are your best friends. N is your reset button. When you press it, it briefly turns off and then turns back on the 3.3 volt power to the chip, giving it a fresh start. The boot button helps get the board ready for a new program. When you hold this button down while pressing the reset button, it tells the ESP32 to go into a special bootloader mode, which is how your computer can upload new code to it. Now, here is a cool thing about many modern ESP boards. You often don't need to manually press the boot button when uploading codes. That's because the USB to UART bridge chip on the board can automatically control the necessary pins, in our case GPIO 0 and EN, to put the ESP32 into bootloader mode for you. This makes uploading new programs much more convenient. This is the LDO voltage regulator, taking 5 volts from the USB down to a safe 3.3 volts. Now, Why does it does that? Well, the ESP32 chip itself is designed to work best and safest with 3.3 volts. If you give it too much voltage, like the 5 volts that comes from a standard USB port, it could get damaged. This is the USB to UART bridge. Usually a CP2102 or CH340 chip that lets your computer talk to the ESP32. Think of it as a translator. Your computer speaks USB and the ESP32 speaks UART, which is a simpler way for chips to talk. This chip translates between them so you can upload your code and see messages from your program. Okay, the main event. The pins. Let's start with power. You have got VIN for external power, like from a battery pack. This pin can take a higher voltage, usually between 5 and 12 volt. And the onboard regulator will step it down to 3.3 volts. To minimize heat generated by the regulator, it's best to keep the input voltage closer to 5 volt to 7 volt range. You have G and D pins for ground. Ground is like the common reference point for all the electricity in your circuit. Everything else is measured against it, and it's super important for keeping your board stable. And this super useful 3 volt 3 pin, which gives you a clean 3.3 volt output to power your sensors. You can also use this pin to input 3.3 volts if you have a regulated power supply, but be super careful because it bypasses the onboard regulator. So there's no protection if you accidentally give it too much voltage. Now, the ESP32 chip itself has 34 programmable GPIO pins. On this development board, you will find many of these pins broken out for you to use as general purpose input output pins. These are your digital control pins. You can tell them to either read a signal like if a button is pressed or send a signal like turning on LED on or off. And a cool thing is all of them can trigger an interrupt, which means the ESP32 can instantly pause. But here is the golden rule. The one thing you absolutely need to remember, not all pins are created equal. Some pins marked here in green are safe to use for anything. Others in red you should probably avoid. And some in yellow are strapping pins, specifically GPIOs 2, 5, 12 and 15. These pins are like special switches the ESP32 checks only when it first starts up to decide how to boot. For example, if GPIO is held low when you power on, the ESP32 thinks you want to upload new code. If you have a sensor or another component pulling one of these pins high when you power on, your board might refuse to upload code or even boot up correctly. And remember the worst offenders, GPIOs 34, 35, 36, 37, 38 and 39 are input only. You can use them to read a button, but you can't use them to light up an LED because they can't send out a signal. Also, be careful with pins like GPIO 1, GPIO 3, GPIO 5, GPIO 14 and GPIO 15, as they can briefly change their state, go high or send a PWM signal right when the ESP32 boots up, which could cause unexpected behavior if you have things like relays connected to them. With the warnings out of the way, let's unlock the fun stuff. The ESP32 GPIOs aren't just simple on-off switches. They have incredible built-in superpowers. You have probably seen the little squiggly line, the tilde symbol, next to a bunch of pins. That means The pin is capable of PWM or pulse width modulation. Imagine you want to dim a light, not just turn it on or off. PWM does this by rapidly switching the power to the light on and off so fast that your eye can't see the flickering. The on time of each pulse, called the duty cycle, determines how bright the light appears. The ESP32 has 16 PWM channels that you can assign to almost any GPIO pins you want in your code. This is how you go beyond simple on, off, and do cool things like controlling the precise speed of a DC motor. Now, to sense the world, you need the ADC pins. The ESP32 has up to 18 of these analog to digital converter channels, and they have a 12-bit resolution. Analog signals from the real world like temperature or light are continuous. An ADC takes a snapshot of that analog voltage and turns it into a digital number. A 12-bit resolution means it can read a voltage as a number from 0 to 4095. That's 4 times more precise than a standard Arduino's 10-bit resolution. This is how you read sensors like a potentiometer knob or a soil moisture sensor for your smart plant project. ADC has 8 channels typically attached to GPIOs 32 to 39. ADC2 has 10 channels attached to GPIOs 0 to 4 and 12 to 15 and 25 to 27. Just remember the pro tip. If you are using Wi-Fi, you cannot use the ADC2 pins because they share hardware with the Wi-Fi radio. Stick to the ADC1 pins in that case. But what if you want to create your own analog signals? For that reason, ESP32 has 2 DACs or digital to analog converters on GPIO 25 and 26. These are 8-bit, which means they can create 256 different analog voltage levels from a digital number. This is awesome for generating simple audio waveforms to play sounds through a speaker. My absolute favorite feature has to be capacitive touch. The ESP32 has 10 touch sensitive pins. You can literally just connect a wire to one and it becomes a touch button. How does it work? Your finger, being conductive, changes the tiny electric field around the pins, and the ESP32 can detect that change in capacitance. This is perfect for making a custom keypad for a security project or a sleek hidden interface on your project. Of course, no board is an island. It needs to communicate. The ESP32 speaks all the major language. UART serial communication. It has 3 of them. UART stands for Universal Asynchronous Receiver Transmitter. It's a simple way for 2 devices to talk using just 2 wires. One for sending, which we quote it as TX, and one for receiving, which we quote it as RX. It's asynchronous, meaning they don't need to separate clock wire. Just an agreed upon speed called the baud rate. UART 0 is used for the USB, but UART 1 and UART 2 are free for you to use with modules like a GPS for location tracking. And if you need to connect multiple devices with just 2 pins, you will use I2C. I2C stands for Inter-Integrated Circuit. It's a smart bus system where a main device like ESP32 can talk to many other devices using only 2 wires. SDA serial data and SCL serial clock. Each device has a unique address, so the ESP32 knows who it's talking to. The default pins are SDA on GPIO 21 and SCL on GPIO 22, and they are perfect for hooking up an OLED screen and a bunch of sensors all at once. And for things that need pure speed, like a full color display or an SD card, you will use SPI. SPI stands for Serial Peripheral Interface. It's a super fast communication highway that uses 4 wires to send and receive data at the same time. The ESP32 has 2 of these high-speed interfaces available for you to use. So you would cover for an demanding peripheral. And there you have it. That's the complete tour. You now have the map to every pin on this board. You know what they do and have real world examples for how to use them. So in the next video, we are taking our steps to the next level. If you are ready to start your ESP32 adventure and level up your coding game, do me a huge favor and hit that like button and subscribe so you don't miss out on the rest of the series. Make sure you ring that notification bell. What's the first project you want me to build with your new ESP32 knowledge? Let me know in the comment below. Thanks so much for watching, and as always, keep making. Bye.